Check it.
Okay, welcome back. Today we're going to be talking about composition of functions. Now, in the last lesson, we learned about operations on functions, arithmetic operations like adding, subtracting, multiplying, and dividing. This is an operation on functions as well, but it's an operation that involves taking two functions and combining them into one function that does the job of both. So if you think about what a function is like a machine that takes an input, does something to it, and kicks out an output. For instance, you could have a function that would take whatever number you gave it, takes your input, okay, you give it a number, and it's going to just multiply it by 3. Multiply by 3, like that. And it's going to kick out an output. So for this machine, let's say you put in a 4 and you get out a 12. So you can write multiply by 3 like I had here, or you can write 3x because you're plugging in an x, right? And this is taking the x and multiplying it by 3. So this is one function, and we can call this function, I don't know, we'll call it f of x. And let's say we have another function, g of x, and its job is to add 5, okay? So you give it an x, and it adds 5, and that's your y. So for instance, if you give this function a 4, it adds 5 to it, you get a 9. That's the job of g of x. And you might, instead of writing the word add 5, you might just say, well, take the x and put a plus 5 in front of it. There you go, x plus 5. And that does the same thing. But what if you took these two functions and you put them together? Could you create a bigger function, call it h of x, that does the job of both of these? So for instance, let's say I wanted to create a function that does both add 5 to your number and then also multiply it by 3. And let's say I wanted the adding of 5 to happen first. So this part right here, this function right here would be first on line, and this function right here would be the second to happen. And what I wanted to do was connect them. So instead of having specific numbers here, what I want to do is connect the output of this function to the input of this one. So like this, I want to take some x that goes in here, it's going to get run through this function here, it's going to go out of here, but then directly right into this other function here, and then come out. So now what would happen if I put in a 4? If I put in a 4 now, what would happen to it? Well, going through this function, it becomes a 9 because 4 plus 5 is 9. And then going through here, 3 times 9 would be 27. That's what happens when you run this 4, this number x here, through two functions. Through the first function, it comes out to be a 9, but then through the second function, it comes out to be a 27. So I want a function h of x that does the job of both of these. That if I put a 4 into this function, I will get out a 27. That's called composition of functions. You're taking two functions and basically merging them into one big mama function. And that function will do the job of the two smaller functions. What if I were to switch the order of these two here? What if I were to take these two functions and put, right now g of x is going first, f of x is going second. What if I took these two functions and switched the order that they are? So I'm going to just make a copy here, and in my little diagram here, I'm going to just trade places. And I'm still going to put the same 4 into here, and the 4 is going to go through the f of x function first now. Whatever it is going to come out, go directly into the next function, and then come out over here. The question is, will it be the same 27 that I got last time? It's the same two functions, right? Won't I get the same result? Well, let's see. If you put a 4 into f of x multiplies it by 3, so 4 in here becomes a 12. And now 12 is going to go into g of x, whose job it is to add 5. So 12 goes into here, and it becomes 12 plus 5, which is 17. So no, we get a different number. So what does that mean? It means that order matters. Which function you put in first does affect the answer. Okay? So this function up here, where the g goes first, okay, this is going to seem a little backwards, but we call this f of g of x. And there's two ways to write this symbolically. You can either write it as f of g of x, or the textbook writes it f with a small circle, a little bubble here. Don't mistake that for the dot for multiplication. It's not. F of g, and it's also pronounced the same way. It's pronounced f of g with square brackets of x. So both of these are pronounced exactly the same way. They're both pronounced f of g of x, or f, this little bubble here is pronounced of, f of g, and this is of x right here. Just like you have f of x like that, f of x, f of g of x. So it seems a little counterintuitive that the f is coming first, even though the g is the one that's happening first, but that's the way it works. And you'll see why in a few minutes. I'll explain exactly why. And here we have f of x happening first and then g of x happening later. This one's actually called g of f of x, or and this is, by the way, this first one's called Euler's notation. I know it looks like it's pronounced Euler, but it's pronounced Euler. It's spelled Euler. Euler's notation, named after somebody who invented large parts of calculus. Or you can do it with composition notation, which is square bracket g little bubble f and then the of x like this. We're going to be working with both notations, so get a good look at both of them. You're going to see both of them right now. Okay, so that was the visual intro of what we're doing. Now let's actually go ahead and do it. So I'm going to give you two functions here, and I'm going to ask you to find f of g of x and g of f of x, meaning find me a function that works in both directions. And the first thing I want to do is try it. You know what? Let me try it with the two functions that we had up here. So let our g of x be x plus 5. So let me just call a little audible here. Let's make this x plus 5, the function that we used above, and let's make this one 3x. So now the functions match what we had before. And we know that when we took f of g of x of 4, we got a 27, and we took it of g of f of x, we got 17. Let's see if we get the same thing here with our master function. So what you're going to do is this. You're looking for both of these. So let's do the first one first. We'll do this one first. F of g of x, aka also known as f bubble g of x, right? F of g of x that way. But I'm going to stick to the Euler's notation for now. And this is going to be one function that does the job of both. Okay? This is going to be the h of x I made mention of up here. I said, could we find one function called h of x that does the job of both f and g? This is going to be it right here. This is like what h of x would be. And the way this works is actually pretty simple. The reason why I like to write it in Euler's notation is for this reason. You can clearly see that the g is inside and the f is outside, right? Outside the parentheses. So the inside function, gets done first, which is why, that explains why they're in the order here. The function that goes first is the inside function, and the function that is outside is the outer function here, the second function. So what you're going to do is take the outside function, the one that's outside, which in this case is f of x, which is 3x, and you're just going to write it right here. However, okay, you're going to copy that. However, wherever you see an x, you're going to replace that x with an empty set of parentheses. Now, I'm not going to keep calling it empty set of parentheses because that's a lot of syllables. So I'm just going to call this thing here, the empty set of parentheses, I'm going to call it a blank. So 3x becomes 3 blank, empty set of parentheses. That's the outside function f. Now, what's the inside function? The inside function is g of x. That's your other little function machine from up top. And this function is x plus 5, and this goes inside f here. So it goes here, like that. And now you can simplify. F of g of x is simply going to be 3 times x, which is 3x, plus 15. This is my composed function, f of g of x. Now, let me test it. What is f of g of x if I plug in a 4? Okay, well that would be called f of g of 4, wouldn't it? And that would be 3 blank plus 15, where the blank is a 4. And 3 times 4, in most countries, is 12, plus 15, that's the 27 that I got up here. There it is. So it works. So if I want to, and there's no reason to really have to do this, I could write myself a new function called h of x, right, which is the same as this, 3x plus 15, and that would be a function that does the job of f and g. Or I can just call it f of g of x. Okay, I'm not going to bother with the h of x. That takes care of that. Now, what if we switch the two functions, okay, where f of x is going first and g of x is going second, okay, and that gives us, for the same 4, we get a 17. Let's see, how do we find that function? Okay, so what we're going to do is acknowledge the fact that g is on the outside now and f is inside the parentheses. You take the outside function first. So if this was written, by the way, if this was written with the bubble notation, like this, g of f of x like that, it's the first one. So if you're looking at Euler's notation with the parentheses, then the one outside is the one you want to use first. And if you're looking at the bubble notation like the book has, well, the first one is the one you want to do first. It kind of makes sense, right? So take the first function, which is g of x, and copy it here. So that we want g of f of x equals, take the first function, which is x plus 5, and write it here. But you're not going to write x plus 5 like that. You're going to write empty set of parentheses plus 5. In other words, blank plus 5, like that. See, wherever there used to be an x, put an empty set of parentheses with a big enough space that you can fit the next thing inside of it. The next thing is going to be this, whatever this is. In this case, it's f of x, which is 3x, and that goes in here. So now we simplify. Well, it's already pretty simple, actually. 3x plus 5, right? So g of f of x is 3x plus 5, and let's test it. What's g of f of 4? We're expecting it to be 17. If you remember from up here, it should be this number right here. Let's see if it works. It's going to be 3 blank plus 5, and you put the 4 in here. Well, what is 3 times 4? 3 times 4 is 12, plus 5, isn't that 17? Yeah, looks pretty good. Looks like it's working. And this is how you compose functions. Now think about it. The word compose means to put things together. When you compose music, you take notes and you put them together into a piece of music. When you have a composition, okay, you're putting together words into a story or whatever in your little composition notebook, right? So composing is taking things and putting them together. We're composing functions, taking smaller functions and putting them together into one big function that does the job of multiple functions. All right, let's try another one. So this one here, this time I've written it with the book's notation, with the bubble. Okay, but I encourage you, whenever you see this bubble notation in the book, to rewrite it, at least mentally, if not literally, in the other notation, which is this way. Why? Because it's so valuable to see that one is inside the other, that this function is the inner function, this is the outer function. So that's what we're looking for here. And for here, we're looking for g. This is pronounced g of, the bubbles of f, g of f of x. Well, this is also pronounced g of f of x. They're both pronounced exactly the same way, just written differently. Okay? I like to work with these a little bit more than these. So in my brain, when I see this, I automatically translate it into this, and I recommend you do the same thing. So let's find f bubble g of x, or aka f of g of x, like that. Well, what's the outer function? The outer function is this one here, f. So I'm going to write it down, 1 over 3x plus 5, but I'm going to write 1 over 3 blank plus 5. So hopefully you can see the same thing here. This and this are identical, except where there was an x, now there is an empty set of parentheses. And now what goes inside is the inner function, which is g of x, which is this x squared plus 1. That goes in here. And now all I have to do is simplify. So this is basically just distributing, right? So 3x squared plus 3, and then you have the plus 5 there. And I can still simplify a little bit more, because 3 plus 5 is 8. So 3x squared plus 8, and that is my f of g of x. And that's my first answer, but I'm asked for 2 things, so don't get half your credit. Do both parts on the homework tonight and on the quiz when that comes up. So now I have to find g of f of x, okay? G of f of x, or g of f of x. Either way, it's pronounced the same way. So g is the outer function this time, so I'm going to write g first, this one. And this is x squared plus 1, so I'm going to write blank squared plus 1. Okay? And in the blank goes this fraction here, which is f of x. And now how do we clean that up and simplify it? Well, when you're squaring a fraction, you're just basically squaring the top and squaring the bottom. So this becomes 1 squared, which is still 1. And this is going to be 3x plus 5, the whole thing squared. And this plus 1 is still here. Now, how do you square 3x plus 5? You need to write it twice, like this, and then FOIL it out. Okay, distribute it out. So 3x times 3x is 9x squared. 3x times 5 is 15x. 5 times 3x is also 15x. And 5 times 5 is 25. So we get 9x squared plus 30x plus 25. And that's what we're going to have in the denominator. And there's a plus 1. And we could go further, but that's more pre-calculus, so I'm going to leave it here. Okay. The next part is, well, actually using these composed functions for something useful. Okay, and that is what we did in the example above, which is plug in numbers after you found the composed function. So I have these two functions here, and they're asking me for two different questions here, two different values. They want me to find f of g of 5, and they also want me to find g of f of negative 1. Now, if I asked you for f of 4, for instance, how would you find f of 4? Well, what you do is you would find f of x and plug 4 into it, right? So you take this function right here and you plug in a 4. And you'd plug in a 4 over here as well, right? So f of 4 would be 2 times 4 minus 5, right? Which is 3. That's how you would find it. So to find f of 4, you need f of x, right? To find f of 4, you need a function called f of x. Well, how would you find f of g of 5? To find f of g of 5, I need a function called f of g of x. All right, and over here they want us to find g of f of negative 1. We're gonna find g of f of x, the function, first, and then we'll plug in our negative 1, and here we'll plug in our 5, and we'll find our values. Okay. Now you could do it in two pieces where you find g of 5 first, and then you plug that into f. But we're gonna do it the way that I just mentioned because it's more valuable to us. So let's do this. You want to find g of f of 5. Sorry, f of g of 5. To find f of g of 5, find f of g of x first, and we already know how to do that because we just did it a few minutes ago. You take the outer function, which is f, and you write it here. So 2 blank minus 5, and in the blank goes the other function, which in this case is 4x. And then usually we would, distribute, we get 8x minus 5. But you know what? We don't need to distribute yet because we're about to plug in a 5. So let's plug in the 5 first, here and here. And then we'll simplify everything all at once rather than do the work twice. So f of g of 5, which is what we want, this is what we're looking for right here, is going to be 2 times 4 times 5 minus 5. And now PEMDAS. 4 times 5 is 20, times 2 is 40, and 40 minus 5 is 35. So that is f of g of 5. Now, what about g of f of negative 1? Well, to find g of f of negative 1, we need to find g of f of x, the function, and then we'll plug in a negative 1 when we're done. Outer function is 4x, so we're going to write 4 blank. Okay. Now, we're going to plug in the inner function, which is f of x, which is 2x minus 5, here. Now, to find g of f of negative 1, we're going to plug in a negative 1 for each x, and we'll simplify. PEMDAS says work in the parentheses first. So inside the parentheses, we have 2 times negative 1, which is negative 2, minus 5 is negative 7, and negative 7 times 4 is negative 28. And that's g of f of negative 1. Right there. Now, there is another way to do this. So if you're working with a tutor, you're working with another teacher, whatever, you might be told that you're supposed to do it a different way. We're going to use the other way as our check. Okay? So here's what we can do. When you see that there's a function inside another function, the inside function is the one that goes first. We established that earlier in the lesson. So g of x is going first. It's the first machine online, so to speak, and then f of x is last. So if we want to find f of g of 5, we can find g of 5 first. So let's do that. Here's our check. This is how we're going to check our work. What is g of 5, the inside part here? Well, we have a function right here, 4 times x. This means that this is going to be 4 times 5, which is 20. Once we find g of 5, and we know it's 20, now we're just going to find f of that. What is f of 20? Okay, so this is not the way I want you to do the problem. This is the way you can check your work. Okay, because doing this is actually more valuable to us in pre-calc. Doing this comes up a little bit in calculus later, but we need to be able to do both. So what's f of 20? Well, your function is 2x minus 5, so it's 2 times 20 minus 5, which is 40 minus 5, which is 35. And you can see you get the same answer, so it checks out. Okay. And how about checking this one here? Well, we can find the inside part first. What is f of negative 1? Well, f of x is 2x minus 5, so this is 2 negative 1 minus 5, which is negative 2 minus 5, which is negative 7. And now we can take that negative 7 and plug it into g of x. G of negative 7 is 4 times negative 7, which is negative 28. And yeah, we get the same answers. And I didn't explain this very much, so it seemed faster, but the truth is this is just as fast as this. But I was taking my time explaining all the steps here, where here I'm just kind of breezing through it. But yeah, it works both ways. You can do composition either way, but on my quiz, I'm going to be asking you to find the function first, then plug in the value. Okay, let's try one more example here. Let's try example B here. Example C looks like we've already done it. Okay, so we want to find R of S of 3. Well, if you want to find R of S of anything, you better find R of S of X first. The outer function is R, so we'll write that first. It's x squared plus 2, so we're going to write blank squared plus 2. This is where the x used to be. The squared is still there, plus 2. What goes inside is the inner function, which is S, and that is going to be x minus 6. Okay? Now, we don't need to square this right now, because if we were just looking for the function, we'd simplify right now, but we're actually looking for, R of S of 3. So let's plug in the 3 and then we'll simplify. It's going to be easier. So plug in your 3 here and plug in your 3 here, and you'll get your answer. So R of S of 3 is going to be 3 minus 6 squared plus 2. PEMDAS says do the parentheses first. So 3 minus 6 is negative 3. Then you take the negative 3 and you square it. Negative 3 squared is negative 3 times negative 3, which is positive 9. And that's going to be 9 plus 2 is 11. So R of S of 3 is 11. And now over here, what's S of R of 10? Well, we need to find S of R of X, the function, first. Outer function is S, which is blank minus 6. Blank minus 6. Inside is x squared plus 2. Now we need to find what's S of R of 10. So S of R of 10 is what you get when you make all the x's into 10s. So I'll put a 10 here for this x. And this becomes a 10 as well. So this becomes 10 squared plus 2 in here, minus 6, right? And let's see what we get. Well, PEMDAS, exponent first. So 10 squared is 100, plus 2 is 102, and 102 minus 6 is 96. So that's S of R of 10. Okay, this last one here might look a little weird. It's asking you to find f of g of z. So that might seem a little strange, but don't panic. Once again, it doesn't matter what's inside here. You still need a function called f of g of x, right? Because you're going to plug something in here later. It doesn't matter if it's a number or even another letter. In this case, that's z. So what's f of g of x? Well, the outside function is this fraction right here. It's 1 over 3x plus 5, so 3 blank plus 5. The inside function is g of x, so that's going to be this x squared plus 1, like that. But now we want to, instead of simplifying this, we want to just plug in this thing, z. Wherever you see an x, change it to a z. That's all you're doing. You're just plugging in a z. So what's f of f of g of z? It's just simply, well, this x squared becomes a z squared plus 1 plus 5. And we can simplify that further now. Distribute that. We get 1 over 3z squared plus, that's going to be 3, plus 5. And then finally, 1 over 3z squared plus 8. And that is f of g of z. And we are done. See you at the next video.